In 1948, a new method of dating was created by two men by the names of Irvin Friedman and Robert Smith. This method was called Obsidian hydration dating and was unlike any other dating technology of the time. These geologists saw immense potential in obsidian, specifically in regards to its time-capturing abilities. In 1960, it was introduced to the world of archaeology and steadily gained popularity. Then, in 2002, secondary mass ion spectrometry, or SIMS, became the standard for observing obsidian. SIMS is a technique that involves using an ion beam on a surface in order to collect secondary ions. In order to understand how obsidian dating works, you must first know the chemical properties of obsidian itself. Obsidian is a volcanic glass containing 0.2% water. When it is cut and therefore exposed to the atmosphere, it attracts more water to its surface. This creates a water-based rind around the obsidian that grows with time. From this knowledge, we can see how obsidian hydration dating works. The larger rind obsidian has, the older it is. There are multiple pros to this method. To start, it is incredibly cheap, especially when in comparison to other major dating methods. All you need to successfully execute this method is a high-powered microscope. This makes obsidian hydration dating easily accessible to almost anyone. Another advantage to this method is its ability to be a relative or absolute method of dating. Here's the breakdown of what this means. Relative dating bases a timestamp off of other remains. It can't place a certain year on an object, but rather how old or new it is in comparison to something else. While this is useful in many ways, it certainly has its limitations. This is where absolute dating comes in. Unlike relative dating, an actual time frame can be placed on the object, which is arguably more useful. While there are certainly pros, there are many cons as well. The most noteworthy one is that there are so many variables that can make the dating inaccurate. Temperature, for one, makes the process much faster. This also ties into elevation, with lower elevation obsidian artifacts developing a rind faster than at higher elevations. Another downside is that obsidian is not abundant everywhere in the world, and therefore obsidian hydration dating can only be done at sites where it is. Overall, obsidian hydration dating can be a useful tool for placing a timeline on artifacts. However, due to its drawbacks, it is not the most popular method, rightfully so. It's important to consider these downsides when using obsidian hydration dating in order to get the most accurate results possible.